This video is going to be an introduction of linear functions. A function whose graph forms a straight line is called a linear function. Notice that in the word linear it says line. That's where the straight line comes from. Now a parent function is the simplest equation of a function. The equation y equals x, or f of x equals x, is the linear parent function. Well, and what that looks like, if you go in your calculator and put in there y equals x and press graph, right here, that is the parent function. From here, all the other equations happen, like we may translate them, move them up and down, right or left, make them steeper or flatter, but this is the basic one. Linear functions describe numerous real-world situations that involve consistent rate of change. Such as cost, distance, and speed. There are three ways to identify if a given set of data is linear or not. One of the ways, I can't seem to get my pen here. It always disappears on me. One of the ways is right here by the line. So if I go here, and one of the ways is to look at the graph and see that it makes a straight line. So one of the ways is by graphing. Another way is just by looking at the equation. If it has just a regular x where the exponent is a 1, now remember that 1 does not have to be shown, we'll know it's linear. The other way is through a table. Oh, I need to get my pen here. Your table. When you go through a table, if you go through and you do delta y divided by delta x, so you go through your tables and you find that delta y divided by delta x is the same, then that means it's linear. So these are the three different ways that we can find out if the data is linear. So for example, table, ordered pairs, etc. If given a set of data, such as a table, ordered pair mapping, making a table to find the rate of change would help us find if it's linear. Linear functions must have a same rate of change. If the function is linear, then you can find the equation for the data. So right here, I'd go and do delta y, just like we've been doing, which is plus 4. Right here, from negative 5 to 5 is plus 10. I have plus 6 and plus 6. Well, some people go, oh, well, this isn't the same. Well, we're not done yet. You have to find the rate of change, which is delta y over delta x. Remember that rate of change is the same as delta y over delta x. Another word for this is the coefficient. So now I come over here and I get plus 2, plus 5, plus 3, plus 3. So now delta y divided by delta x, I get 4 divided by 2, and that's 2. 10 divided by 5, that's 2. 6 divided by 3, that's 2. So since all of these rates of change are the same, then that means that my data is linear. And from here, remember, so that means that if I graphed these points, it would give me a straight line. And I also from here can go and find the equation of the line. So right here, here's the next example. Pause the video and see if you can figure out if the equation is linear or nonlinear. If it is linear, then you want to make sure and go through and write your equation. So the first thing I would do is delta y, the change in y right here, minus 5. Right here, minus 3, minus 1. And that's actually plus 1. It's going back up. Delta x, the change right here, plus 1, plus 1, plus 1, and again, plus 1. So now if you go through delta y divided by delta x, Negative 5 divided by 1 is negative 5. Then I have negative 3 divided by 1. That's negative 3. Already I don't have to go anyplace else because see how these are not the same? This is nonlinear because you cannot find the equation. Right now we cannot find the equation of this data because delta y over delta x is not the same. So right here where it says equation, there's none. We can't do anything with it. You leave it alone. Here's the next one. Pause the video and come back and see if you can figure out if it's linear or nonlinear. Delta y, the change in y, is minus 3. Right here is minus 6. Going from negative 4 to negative 13 is negative 9. And now I'm going back to negative 3. Delta x right here, plus 1, plus 2, plus 3, plus 1. So now I do delta y over delta x. I get negative 3 over 1, which is negative 3. Negative 6 over 2, negative 3. Well, then there's one more. Negative 9 over 3 is negative 3. Now, since all of these are the same, oh, not that one, that one. That means that it is linear, and I can find the equation. So there's not a whole lot of room over there, so I'm just going to open this up here. And I'm going to pick one of my points. It doesn't matter which one. I'll start at the top and go negative 2 and 5. Remember, this is x, then y. So I'm going to put negative 3 in here times my x, which is negative 2. When I multiply these two together, I get positive 6. What do you have to do to positive 6 to get to 5? Minus 1. So my equation is y equals negative 3x minus 1. Don't forget, you need to go in your calculator and go to y equals and put in there negative 3x minus 1 and press second graph. And, well, that's way far away. Let's go back up here to 0. Second graph. And go and look and match up all your points in your table to make sure that you've done it correctly. Next, here's another one. We need to figure out if it's linear or not. So the first thing I would do is I would take my points and I would make a table. So I have negative 10 and 10, negative 5 and 4, 0 and 2, and 5 and 0. And then I always put an x right here. Okay, remember this is x, then y. Now I'm going to find delta y, the change in y right here, minus 6, minus 2, minus 2. Delta x, plus 5, plus 5, plus 5. Let's see about this. I've got delta y over delta x. I have negative 6 over 5. Okay, what about the next one? Negative 2 over 5? Wait a minute. These are not the same. If they are not the same, they are nonlinear, and we can't do anything else. Here's another one. Pause the video and see if you can figure out if it's linear or nonlinear. If it's linear, then find the equation. So I'm going to build my table. Remember, we have x, then y. Let's go in here, and I've got 2, 4, 5 and 3, 8 and 2, 9 and 1. Now again, I'm going to go in here and I'm going to put my x in here. And I'm going to go through and I'm going to find delta y. The change in y right here, minus 1, minus 1, minus 1. Delta x, the change in x, plus 2, plus 3. Oh, what did I do plus 2? I was wrong right there. Whew. All right, here we go. That is plus 3. And then this one, and then let's see. So that's plus 3. This is plus 3. This right here is only plus 1. Delta y over delta x. I have negative 1 over 3. Then I have the next one, negative 1 over 3, same thing. The next one, though, is negative 1 over 1. These are not the same. This is nonlinear. Next one, let's look at these graphs. Well, okay, I told you linear means a straight line. Does that make a straight line? Sure enough. So this is linear. What about this? This does not make a straight line. Whoa, I just was circling linear. What am I doing here? This is nonlinear. When you have this U-shaped looking thing, this is actually called a parabola. We will work on this later on. Next, let's look at this one. What about this one? Does it make a straight line? No, you can tell it doesn't, and it is nonlinear. The next one, look at number 9. Number 9, is that linear? Does it make a straight line? Sure does. Number 10. Look, it gives us an equation, and we need to figure out if it's linear or nonlinear. Well, one way you look at this, and I see that it's just a regular x. I know that it's linear. But right now, let's go, let me move this calculator over here because we are going to have this with us to help us. Let's put in there negative 4x minus 7. Press graph. It makes a straight line. Whoa, why do I keep circling, almost circling the wrong thing here? I'm going cuckoo here. This is linear. It makes a straight line. Next one. There's the next two. Put those in your calculator and come back and see if they're linear or not. The first one, let's see, I have 1 divide 4 x minus 8. I press graph. There's my line. It's going in a straight line. It is linear. I put that back up there so you can see. Let's try this next one. Go in the calculator. I'm going to put, let me clear it out. I'm going to put 1 divide x plus 3. And I'm going to press graph. Oh, that's one of these little funky things. This is non-linear. Look at that one more time. See how it curves this way and then curves up? That is non-linear. Here's another one. Let's look at this and see what we can do. It says make a table of data and write the equation. If you can write the equation in the form y equals the coefficient x plus the constant, then the problem is linear. Right here it says John receives a gift card for $25 gift card for iTunes. The cost of each song is $1.25. How many songs can John buy before running out of money? Okay, well, let's look. First off, what is it he's buying? He's buying, so we're going to have the number of songs. And this is going to be his gift card. So when he first gets his gift card, he hasn't purchased anything yet, he has $25. The first song, after he gets the first song, subtract off $1.25, so that is $23.75. The next song he purchases, you take off another $1.25, so it's $22.50. And the next one, another $1.25 is, let's see, what is that? $21.25. I don't really have to go on any more than this. When I go to make my equation, I can look here, and you can do it a couple ways. You can do delta y over delta x, or I can look and see and go, okay, wait, I'm starting with 25, and I'm subtracting off $1.25 for each song. So here's my equation. I can write it this way, or I can write it y equals negative 125. Now remember, the coefficient has to be negative. The constant has to be positive, otherwise you'd be making the money negative. If you put this in the calculator, it's going to give you a straight line, and it is linear. The next one, Katie starts with $15 in her bank account, and each month it doubles. How much money does Katie have after 5 months? Okay, so right here, we're talking about money in the bank. And this is going to be the number of months. Well, first off, she starts off at 0 months. She starts off with $15 in the bank. After 1 month, her money doubles. That means this goes to 30. The next month, this doubles again. That goes to 60. Well, the third month, if this doubles, it goes to 120. Okay, so let's see about delta y over delta x. If I do delta y right here, plus 15, this one is plus 30. And then I have plus 60. Then delta x plus 1, plus 1, plus 1. I have delta y over delta x. So now I've got 15 over 1 is 15. 30 over 1 is 30. Well, wait a minute. These are not the same. My rate of change is not the same. It is nonlinear. Let me give you a hint. If you have something that says doubles or triples, it is going to be nonlinear. The next one, and I've got, it says Heather works at Kroger's where she earns $6.75 per hour. I've got number of hours, and the y, the dependent, is her total pay. Independent is the number of hours. So at 0 hours, she makes 0 money. After 1 hour, she makes $6.75. After 2 hours, she makes, what is that, $13.50? You can start here and you can do delta y, $6.75 plus $6.75, and delta x plus 1 plus 1. So I have delta y over delta x, 675 over 1. So my coefficient is 675. Y equals $6.75 times x. Now I could put plus 0 over here, but I don't need to. This is my equation. It is linear. Let's do a recap. I have y equals 2x minus 4. Remember that the number, well, let's do it this way actually. Let me change some things around. Let's do y equals negative 4 plus 2x. Take a minute and try and figure out which number is the constant and which is the coefficient. Right here, this minus 4, a lot of people are going to tell me it's the coefficient. It is the constant. The coefficient is the number that goes with the x, and this is the coefficient. We also call it the rate of change. We call it delta y over delta x, rise over run. Now, out of these two, which one is the independent and which is the dependent? The y is the dependent. It is the last thing, the dependent variable. It's the thing here at the end. The x is the independent. It's the thing that we first multiply by. Remember, this is also, the independent is also called the domain. Dependent is called the range. We have x being the term number and y being the value. What other ones could I be missing? Can you think of any others? There are still more vocabulary words to come, but this should help us for right now.